Good evening. Let me welcome everyone to the webinar dedicated the process control. Together tonight with VTOs of Sonic, we are here to discuss with you the idea of the process control in terms of process capability. Before we will start, we would like to give you some time to join and to write on the chat from where are you from, what is your name, and what are the responsibilities. Okay, so who is with us? We have first people. Tonight we're streaming on the YouTube, on the Facebook, and on the LinkedIn. So I hope you will pick up your favorite platform for joining us for the nice discussion. The topics regarded as not that easy one. And during working in my experiences with quality, I must tell you that during the audits or even while doing trainings, I observed that people have some doubts how to interpret and how to work with this process capability. So who is with us? Let's have a look who already joined. You can write from where are you from. We have Bulgaria. Travel proof. Good. On LinkedIn, we have here India. Hello. Who else is with us? Fry, and I'm quality engineer. And Pedro, Portugal. Hello, Pedro. Patrick from Poland. No, but later from Luxembourg. Okay, good. Macedonia. We have here also who? Stuttgart. Oh, yes, we have Germany. Okay. Who else? Oh gosh, it's Poland too. We have Romania. Who else? Morocco. Okay, so it's quite international tonight. Locally to my origination, Poland. Brazil, yes, I was wondering if there is someone who is from different continent. Not only, of course, we had already India, but Mexico. So we need to adjust to the different time zones. In Poland again. So generally, I'm very happy. We're more and more. Definitely. We really appreciate that some of you really decided to spend your evening with us. For some, it's still middle of the day or late in the night. So I'm very happy that tonight we can be here with you and have a nice discussion with you, because really would like to hear your voice. Okay, we have also Turkey and again Germany. There are more and more people writing on the chat, so I'm really very happy you are active and you're saying hello to us. So my proposal is, when you're slowly joining, we would like to maybe start. Okay, let me at the very beginning display the presentation of what we prepared for you tonight. I will be telling tonight because in Poland we have 8 p.m. already. Vit, where are you located?
I'm in Belgium, so same time zone.
Okay. Dears, let's start then. At the very beginning, let us introduce for yourself, because you may not have previously experiences with joining maybe quality-wise webinars. Or have any other possibility to maybe get in touch with quality-wise. At the very beginning, I will give the voice to David, who tonight decided to share his knowledge on process capability with us. David, can you introduce yourself?
Yeah, thank you very much, Agata. So good evening, good day for everyone. My name is Staniek. I'm origin from Czech Republic, so not that far from Poland. And I'm working as European Quality Manager in one big international company, where before I have been working for 19 years in one of the biggest OEM world, and I have been working there on different positions, basically as a SQA, as a QA engineer, and then later on I have been working also in the European headquarter, also as a quality engineer, and I was responsible for variety of the commodities for the overall vehicle, then for the brake especially, and then later on for the engines. And just simple, of course, my hobbies typically are the cars. So I like to repair the cars and to play with them. So that's in a short.
So I believe everyone is convinced that we had enough experience to talk tonight with us about the process capability, especially definitely while working with such difficult products like even engines, what you mentioned. Definitely process capability had to be maintained, yes. Myself, my name is Agata Lewkowska. I'm the founder of QualityWise. I'm a quality management system consultant, trainer, and auditor, and I'm supporting actually companies right now with quality management, and the core is automotive industry, because in my opinion this is really very challenging and therefore interesting industry. And so this quality is actually this what I really like, and especially building the awareness and understanding of this, what has to be done in terms of having the, let's call it, robust automotive supply chain. Yes. And let me just briefly introduce you also to QualityWise. QualityWise is offering trainings, audits, and consulting activities for the not only actually automotive supply chain organizations. So we are supporting also others, other organizations. And this is a network of the trainers, consultants, and auditors. So we are working worldwide, in fact, and actually in different languages. So if you feel like you would need some support from our side, get in touch, visit QualityWise website, and I hope we can support you and resolve your issues and strengthen quality assurance. Okay, let's start with our topic. So, during the QualityWise webinars, I'm really keen on your answers. So let me ask you a few questions during tonight's webinar. So at the very beginning, how do you think? Who stands behind process capability? Who is the father of this? How does this start? I will be waiting for your answers and displaying them. This question is actually a contribution to this. Actually, this is actually the appreciation of this, how these people contribute to the SPC and process capability. So, how do you think? Because now, when we are working in 21st century with this topic, we are concentrating on the operational activities, but it will be good to dig a little bit deeper into the roots. How do you think? It started at the early 20th century. So let me maybe help you. Do you recognize these two gentlemen? Who read the book 4 Days With? Okay, I don't see the answers. Maybe this is the reason that people are concentrating on the operational activities. However, let's do our tribute to those names: Walter Andrew Short and Williams Edwards Deming. Now everything is clear. Yes? Vit, do you want to say something?
Yeah. Yeah, so I will give you a little bit insights to know that we basically, thanks to these two gentlemen, to use in our daily life and quality, the things like statistical process control and capability. So a little bit about the Walter Andrew Schuhart. So basically, both of those guys were Americans, right? So they were physics, mathematicians, and statisticians, both of them. They live relatively close to each other. So basically, Andrew Schuhart, we are talking about around 1920s. And basically, he is the guy which introduced the statistical quality control. So that's the what we call the father of the statistical quality control, where the Edwards Deming, basically, he was also a professor on a university, and his basically contribution was that he took the basics defined by Schuhart and he extend them, and he also add a level of the philosophy on top of it. So basically, this guy introduced what we all know is a PDCA. So PDCA cycle has been introduced by Mr. Deming, and basically he also through his um, seminars and consulting, he basically was founder, or he put the roots of the Japanese boost of the manufacturing excellence after the Second World War. So if you will look from the today's perspective, this guy, it gives us really a core things like PDCA. He gives the fundamentals of the lean manufacturing, and also you can see his footsteps in the Toyota production system. So very important guy, both of them actually.
Mm-hmm. Okay. It's really important that you said that this is a fundamental part of the production system, because actually Deming had a mission to, to go to rebuild Japan after the Second World War, and that's why a lot of science and this what we have right now in the quality control is from also that time. Yes. Okay. So let's keep going. What we can say about the practical application. Wait, first.
Yeah,
Automotive.
so obviously automotive. So of course we are using basically the statistical techniques to assess, for example, our suppliers and try to ensure that we have the zero defects in our production, right? So the first, automotive. Yeah, the second one, of course, obviously aerospace. So in here we are looking also for the high precision, for example, for engine components, for blades or whatever in there. So we would like to be sure that everything is right and correct in airplanes, right? We don't want to have the falling down of the plane. And it's electronics and healthcare. Of course, even here we need to take care about the things. And for example, in this particular aspect, we are looking a lot for regulatory and safety standards. So what we can see here, we are talking about automotive, aerospace, healthcare, but across all of them, there is not, I would say, single thing like healthcare is care about the regulatory or safety. So all of them care about the same thing, and that's where the statistical control it's coming into the place to help in all the aspects of the different industries. So it doesn't really focus only for specifically automotive or only aerospace or only healthcare. It can be everywhere. It can be also in a building construction.
Okay. So we are here to talk about the process capability, but is the process capability meaning the same as SPC? What is the linkage? So this is our question to you. We would like to know, how do you understand this notion? Yes. Is it connected. Definitely, it must be connected to SPC. However, does this mean the same? Or this is maybe a wider or narrower perspective of the process management and control? Write on the chat, please, your answers. We will display maybe some.
I'm particularly curious about this one and how the people understand what is a SPC, what is a capability. Is it the same? Is it different? So that's where I see sometimes that people not always know the difference and they put it all together. So
in automotive industry, of course, we have also the requirements from the IATF 16949 system QMS requirements that we need to understand some statistical notions like even process control, process capability. So if you are from automotive industry working in automotive manufacturing, definitely statistical process control must be applied. But here, additionally, there is a clause, another one, 9113, which really states that we should understand some notions. Okay, what we can here can read, SPC can be applied only for stable processes. Oh, okay, this is true. This is the prerequisite for using SPC, definitely. This is a good answer. SPC is a tool to check if process is capable. Okay, also good answer. Capability versus performance. Any other ideas? I see only those three. But anyway, I think they're quite nice, and I really like this. Everyone should really pay big attention to this, what Dimitar wrote. Yes. Also, continuous improvement shall be done when the processes are stable. Yes. Another, both are different. Capability compare process output versus specification, while SPC, you have control chart with upper and lower control limits. Oh, nice answer. It's linked together. Process must be statistically suitable, and then we can go for next step to looking for capability. Also very nice answer. SPC is a tool to assess process capability. Okay, so we're much closer and closer. I like these answers. So, okay, Vit, let's do this comparison. It's
so
quite a lot of information here, but I think I will give you the voice.
Yeah, sorry. So yes, we actually try to give you here a little bit the comparison between these two. So they are indeed two different things, but very closely linked together. So where basically the statistical process control is used to monitor the production through the statistical techniques on real time, and that's what you know with this control charts where you have, as it was mentioned in the chat, the upper and lower limit, and you monitor through the time basically where you are in production. If you see, and there are different things like trend, you apply the control limits, which are more stricter than the standard limits, then you're supposed to react to bring your process again into the stable condition as close as possible to the normal behavior. So that's what statistical process control is doing, where the process capability ultimately it's looking for the similar thing, but it measures basically if your process is potentially capable to produce okay parts within the given specifications, and then it compares actually your actual process with the specification, which is basically said that the natural variation of the process is the voice of the process, that's called, and it compares to your specification specification, which we call the voice of the customer, right? And or what it tells you is your process possibly capable or not capable to provide you the satisfactory product at the end, where the SPC, it's trying to figure out and distinguish that you properly understand and you control your process and you define or you understand what is your natural behavior of the process, its inherent behavior, or what is abnormal behavior and on which you can react. Maybe we can have one example. For example, what is the natural and abnormal behavior? Very simple one, you manufacture the cube, and in a cube you have a hole. You're drilling the hole through the cube, and you control the diameter of the hole, right? You control one hole by another one, and you put the results into the SPC chart. Then, of course, you have the natural variation within a process, which is considered when you produce the part. You already know about this based on experience, based on calculation, that there will be some variation. And that's what is considered as a normal behavior of the process, standard behavior. But in a certain point of the time, all of a sudden, the hole starts to be bigger and bigger and bigger, right? And then basically, this is recognition that there is something wrong because this is out of your expectation, out of your knowledge, out of your maybe control limit. And that's called abnormal behavior of the process. And then if you detect this one, you're supposed to make the correction immediately.
Okay, so now I believe everyone will understand what is the main difference between process capability and statistical process control, how this is interlinked to each other. So to give you the summary of this link between SPC and process capability is definitely that SPC focuses on monitoring and controlling the process in the real time, yes, and therefore control charts are in use here, yes. However, process capability, on the other hand, measures how well a process can meet specification limits over the time. And also, while SPC keeps the process in the control, process capability determines if the control process can consistently meet customer expectations. Of course, because at the end is the customer as a receiver of the output of the process. So the customer satisfaction here must be maintained. But also to state as a summary together, they ensure stability and capability. So here there is one term, stability. Yes, Vit, what is stability?
Yeah, the stability is a minimum variation in your process, basically.
Process does not change much within the time frame, specific time frame. Is stable. That's why it's stability. Okay, let's keep going. What is the difference between population and sampling? If you are asking about this, definitely this is important. Okay.
Yeah.
This maybe your answers are, of course, highly appreciated on the chat. However, let's maybe keep going here while you may be writing and giving your inputs to this discussion, because here definitely the understanding is quite easy, I would say. So just summarize this, please, that everyone can understand and speak the same language in terms of understanding, sampling, and population.
Yeah, so it's really very simple, but it's important to understand. So the population is talking about entire set of data which you collect over the production. So as much as you can, right? Of course, this is not really a very practical thing to do it in a real world because you have too many data, it costs, it takes some time, you need to evaluate everything. So that's why basically we use the sampling and we took from the population some samples which are representative of the data set, of the data points, from that production run. So they are smaller. We need to have the good enough group of the data. That's usually where we are talking about at least 30 samples. And this gives us a good clarity of the process or the data statistically compared to the big, huge amount of the data, right? Because it's difficult to work with a huge amount of the data. And there is some small thing, because the people very often ask why the 30 samples, right? And actually, this is not that easy to explain. It has some complicated history, but the 30 samples, if I simplify, is based on a rule from statistics, which is called the central limit theorem. And it basically says that if you have 30 or more samples, it starts form the good bell-shaped curve, which we know as a normal distribution, right? So these 30 samples, if I simplify, to remember, it's a sweet spot. This is ideal, what has been identified over the decades in the past as a good amount of the samples, which is representative from statistical point of view.
Okay, so here maybe.
Yeah.
Better to visualize.
Here, that's very simple thing. We can see on this chart, we try to visualize what is a population, what is a sampling. So overall, gray zone is basically a population. That's entire set of your data, everything what you have. You see, it's a lot. So you can choose the samples which are represented by the cross. The different color of the cross means maybe a different production run. So you collect the data from different production run. But what is here important, and what you need to keep in mind for the calculations of the capability, is that the entire population doesn't mean the same thing it's called the same, but it's not the same, right? So if you say one production run, you can say my entire population is one production run. But also you can say that you have multiple production runs and it's my entire population. So you have to be careful if you say what is your entire population. Is it from one production run, or is it across the production run where you take something? So it's not the same. It's very important for next what we will discuss.
Okay, so another important notion, standard deviation. Yes, we need to understand this, because this is actually one of the basic things in statistics. This is the first, and the second. This is also important for our process capability. Okay, so do you understand what is standard deviation? Can you also present your understanding on the chat, what it could be?
Maybe in the meantime, I can give you a little bit the hint how to look on this overall the things about the capability from hierarchy point of view, right? Because if you think about the statistical process control and capability, then you will ultimately understand that the statistical process control is on the top of the hierarchy, and it's not most precise the thing, right? So it's on the top, then it's going down, and the next level is actually the standard deviation, right? That's the second point. Then you have the process capability, and then you have process capability, which is centered, and this is most precise what we have. So there are the levels. As you can imagine, the SPC is on the top, standard deviation is a little bit lower. It gives you already more precise data than CD ability. It gives you even more precise data. Then you have our APPA, and it gives you most precise data, which from statistical point of view.
Okay, let me display some answers. Patrick wrote, measure of the amount of variation. I like this answer. And also I wanted to this comment, difference from the mean value, really very nice. Okay, what we have after learning from Vid himself, I have an understanding. Look forward to seeing a deeper perspective to my projects. Team, we are keeping our fingers crossed for you. It's a measure of the amount of variation or dispersion in a set of data values, I guess. You don't have to guess, Jan. You're very close. And actually, the definition what you gave is like we would expect you to understand. So, what is the standard deviation here? It tells us exactly like you wrote, how much spread dispersed numbers is a set of that how it is dispersed for our data. Yes. So in other words, exactly like you wrote, how far each point data points are from the mean. Yes. And Vit here, how it is with small standard deviation. What does this mean?
Yeah. So only what I can say on the top of it is that if you have small standard deviation, so it means that your data points are very close to each other, right? And distributed very close around the average. So that means that you have the small variation in your process. So your process is consistent. So opposite to that, you have a big spread of the data far from the average everywhere. They are scattered on the extremities. And this is basically saying us that more wider spread of the range of the data is, the less consistent process you have. And that's all what basically the standard deviation is telling us. How close the data are around the average or how far from the average they are. So you can see there is nothing about any limits. It just say how dispersed the data are.
Okay. And just to briefly show you how to calculate and what is the difference in the designating this, yes, how we are writing the standard deviation.
Yeah.
Wait, what is the difference between sigma and S?
Yeah, that's both are basically telling us the standard deviation. The difference here is what we discussed before. What is a population and what is a sampling? And that makes a difference. So the sigma is used typically for short-term capability, right? And it's used the data from one production run typically. So if you would like to calculate in Excel, there is a function for standard deviation, and it's a standard deviation.p, population, and that gives you a short-term sigma standard deviation. Compared to that, we have S, not the sigma, it's S, and it's calculated a little bit differently, but essentially it takes the samples across a different productions, and that's called your whole population. Not one production run, but multiple production runs are your population, and you take a samples of it and you calculate the standard deviation. And that's why in formula, you will see that the function names is standard deviation.s. It's a sample, means sample.
Okay, so now, what is process capability? So straight to the point, this question. When we are talking that our processes are capable, we mean that what is happening with these processes. Before we were saying process is stable and capable, yes?
You can see, I can give you a hint, we are going tighter and tighter. Remember what we said about the hierarchy? So now we are going tighter and tighter.
So, any answers? Probably they will show up soon. Because we have 10 seconds shift in streaming between different platforms. So let us wait a bit. We said that stability means that it was within specification limit. Yes, one of the feature of the process. And now the second feature, the capability. So if the first one was within specification limit, the second one is not only about within specification limit, but also let's display the first one. A process capability is a measure of a process ability to produce output within specific limits or tolerances. Okay, I'm still waiting for this. Stable, similar results capable between agreed range. What Patrick wrote, ability to constantly produce parts fulfilling requirements. Okay, process is capable to produce products inside specifications. Okay, I'm still waiting for this one word. When we're talking about the capability, we're also thinking about how the processes are centered. This I was looking for. What else we see? Helena wrote, statistical index that shows processes able to achieve specification and consistently. Okay, let's keep going. You can still write in the chat. Process capability. Vit.
Yeah, so as I said, so we are going narrow and narrow. So, you know, in standard deviation, we discuss about the spread of the data. Now we add one aspect more. We give the limits to the spread of the data. And we basically compare if our progress is within that limits which are given, right? So that's what is called the process capability index, or you can know it as a CP or PP. So this basically measures your potential capability of the process to meet the specification limit, but assume, same as a standard deviation, that you have the correct dispersion around the average. So it doesn't consider if you are shifted up or down where you are. It just consider, are you within the limits, yes or no, right? And then here have the interesting point. We have, for example, perhaps you heard about the CP, which is equal 1. And plenty of the people consider that if we have the CP equal 1, that we have entire population of the data within the specification limits. That's not true. We have to be careful. That's coming from statistics, from Six Sigma distribution, and it says basically that if our CP is 1, we produce 99.73% of the parts within the specification limits. And that's what I try to show you here on a chart. If you zoom on the area where we have the limits, you will see that the yellow line, which represents actually the CP1, is going away a little bit from the tolerance limit. And this is your 0.27% MOK parts, which you possibly will produce if you have the CP1. And another aspect is that basically what CP is telling us is how many times your population, your bell curve, it will fit within the limits. So if you have CP1, it means that your bell curve will fit within the limits 1 time. If you will have a CP2, you will fit 2 bell curves within those limits, right? So that's what it tells. But it doesn't say, are you drifted from the mean value or not? It just say, are you within the limits? Yes or no?
Okay.
Of course, then it means, if I just summarize, so if your CP is higher, then your process is better. The lower CP means more not good parts possibly you will produce, statistically.
Okay, so let's jump into this process capability index center. This what what we were expecting to also to hear from you, because this is the second portion of this information, the one that we are talking about the process capability. So here, Vit.
Yeah, this is a nice one. We are going again more tighter, and we are going to the CPK. So it's also a process capability index, but here it's centered. So here we are basically looking where we are positioned with our data compared to the not only the limits, but also to the mean, right? So basically it says that it's control the both the data spread, how well they are centered relative to the specification of the limits. And then basically that's our calculation, right? So if we try to calculate the CPK, we are looking for worst scenario. That's why we are looking for minimum. And then we are looking where the process is shifted. And if it will be shifted on a lower level, that will be our minimum, and that will be the worst scenario which we consider for CPK, right? Compared to that, we have the PPK, which is considered as a long-term capability, where CPK we consider as a short-term capability. And I know that some people may dispute a little bit with me that in VDA 4 basically is described that CPK and PPK is long-term. That's all the definitions around. I usually like the precision of the VDA, but in this case, I think the AIAG definition of the short-term and long-term capability gives us better insight of the process and the understanding of the process. So basically, the PPK is a long-term capability, and if you look to the formula, the difference is again what you use for calculations. So for CPK, you use sigma, right? For one production run, you remember. For PPK, you use the sample S. For multiple samples gathered from entire population.
Okay, so I'm quite curious how it will be in next year when we will have a joint manual SPCB and AIG, how they will call it. If right now they are not consistent. We'll see. Okay, let's keep going. What is the difference between CP and CPK then?
Yeah, basically, I was quite thinking how to explain it in a simple way, and it came across that I read some article about what happened on a rails with the trains, and then it kicks me and it says, okay, so that will be a good example. So let's have a look on a picture. So we have two different types of the trains. We have on the left side the Shinkansen from Japan, and we have the Deutsche Bahn from the Germany, or it can be whatever European train. It doesn't matter. I use basically the example of the Belgian trains. For example, say we all know that Shinkansen is very nice, very precise in the time. Where also we know in Europe that unfortunately the normal trains in Europe, they are not that much precise and there are often delays, etc. So let's say that we define our target to be the train arrival within 10 minutes from the declared time, right? So if we look to the Shinkansen, statistically, the Shinkansen delay in 2023, it was 1 minute for all the trains, 1 minute average. When we compare with the European, it was 6 minutes delay. So understand CP and CPK. Okay, so CP, it's tell us the limit. We have 10 minutes. So based on judgment on a CP, the both of them are okay because we said 10 minutes. So Shinkansen can do it in 1 minute average delay, but European trains, they can do it in average in 6 minutes. So they fit in there and they are okay. That's perfect for us. But the different story is if you look to the CPK point of view, because then we say, okay, we are not interested if they will arrive on time only. but how accurate they are in arrival, how stable they are in arrival. And then we can say that Shinkansen will always arrive within 1.1 minutes, very stable, right? Very constant. Where the European trains, they can arrive in 1 minute, 6 minutes, in 5 minutes. The variation, the spread of the data, it's much wider for European trains than for Shinkansen. And that's how we can look for CP and CPK. So CP, it looks, will they arrive within 10 minutes? Yes, both of them, yes, good, perfect. CPK, say how stable they are. So the Shinkansen will arrive, you can be confident in 1 minute. Where the European trains, you don't know. It will be somewhere between 1 and 6 minutes, maybe. And
Okay.
curiosity, just for the
This is good example from the life. It's real life example. However, I remembered thanks to Deutsche Bahn, I had the situation that I was waiting 4 hours at the Bahnhof for a train when I was during my studies in Germany. It was not nice. That's why I picked up the picture of Deutsche Bahn. Okay, the difference between CP and CPK, but just briefly, read. We're close to the
I think that's what we explain, right? The CP is really looking, are you in a specification, and it doesn't consider your alignment with the mean and your position of the data, where the CPK is taking care basically about where the data are centered, right? And that's the main difference.
Okay, so now the difference between CPK and PPK.
Yeah.
Another real life example.
Here we have another example. So of course we said that CPK, we will call it short-term capability, right? Based on IATF. PPK, we will tell that this is a long-term capability. So here we can take an example from a school we all know, right? So we have here the student of the physics, and he do some test. And in the test, his score is pretty good, right? So right now, this test was good. That's perfect. That's short term, he is good. But it doesn't mean that if you look on his behavior over the whole semester, for example, that he is good. Because he may come across the different tests from mathematics, electricity, thermodynamics, or whatever. And we will see that, yeah, he is good. He was good in one test, in one point of the time. But if you look for a semester, maybe he is average student, right? So that's a difference. We don't look, in CPK, we look now, right? Short term. But in PPK, we look for longer period of the time, and we constantly trying to evaluate and consider the future also.
Okay. So now the summary.
Yeah, and basically this chart basically gives us just a summary. What I said: CPK short term, PPK long term. CPK, you're looking for the one production run, typically looking how it's capable in that production run, where the PPK is taking the samples from different production runs that define our population, and it's looking how consistent across the different productions we are. And that's something very interesting, because you may have different shifts, different setups, different incoming materials. So it gives you the longer, basically the long-term capability. It gives you a better knowledge of your process, of your stability of the process. And that's basically why the VDA is looking for long-term capability, because it's more precise and it gives you a better indices how your process is behaving. It takes a time to collect the data, and it's a lot of data. And you need to have something quicker for assessment.
Okay. So now, when the process is considered as capable, we understand already what is the process capability. So now, when?
Look what are the general rules in here and what the AIAG basically is telling us, how it's defined the process, where the capability index centered, usually CPK or PPK, what is the requirement for that one? When we consider this good process, really.
Video inspired me to ask this question. Is IATF saying anything about this in this regard? This is also a question maybe to all of you.
Yeah, that's a good one. That's a good one.
Okay, so let's wait a second. What is your best knowledge? Yes. What are the requirements simply? Yes. If you're working with the processes, if you are process engineers, definitely you need to keep this process capability. Patrick must keep more than 1.3. Okay. Who else? Run at rate in first serial, then check after in serial production PPK. Good. Serkan is also referring to the project management, yes, the new launches, how it is in automotive. Sure, definitely. Before we'll go to the serial production, before we need to validate, and also in this validation is the information about the process behavior. So also very nice comment. Patrick, CPK, I mean. Okay, any other point of views? Here we have ability to keep between lower and upper. Yes, this is the generally how we said about the idea of understanding capability. But now we would like to know when we can say that we meet the requirements.
I like very much the answer with the run and rate, because indeed this is one portion of the requirement, that to make your capability calculation, you have to take the data from run and rate. And then there are the prescription that it should be minimum 300 consecutive parts produced or blah, blah, blah. So there is even the specification, right? Or the requirement given for run and rate. And that's a good answer. That's really good answer. It's linked together.
We have also an answer from Jan. CPC must be 2133. Okay. Let's display what our knowledge about this. Okay,
you will be surprised a little bit.
Yes, we have here two approaches: AIAG and VDA. So you can see here how the requirements are set up. Vit, please comment this.
So you are right. So we all very often hear that the requirement is 1.33 minimum. Yes, but there is big but. If you look on a standard in an AIAG, and specifically it's mentioned in PPAP book, there is clearly described the requirement. And there is written that if the CPK or PPK is equal or bigger than 1.67, then the process is considered as a capable, right? So it doesn't need any other further review, agreement, anything. This is overall accepted, good, capable process. By the way, 1.67 means 99.99994% of OK parts will be produced, and it's approximately distribution of the 5 sigma, just the side. So that's 1.67, and this is considered as a capable process. Where in a standard, what we oftenly hear, it's basically 133 minimum. The standards say that yes, this may still be accepted, but must be approved by the customer. So in default, 133 in AIAG standard is not considered as a capable process. It's considered that it may be capable if your customer agree with, right? And of course, if you have below 133, I will use a dirty word, is a crap. That's not good process from statistical point of view. It doesn't mean that it's not good, but statistically, it's not good.
Mhm.
And we have actually the same things in VDA. They are basically decide the same thresholds.
Mhm. It's worth also to mention here about the special characteristics. Mhm.
Oh yeah, that's a good point. That's a good point. For special characteristics, especially if you have the safety, regulatory, or another, so whatever special characteristics, then typically is required 1.67 CPK or PPK.
Mhm.
And again, there is a room, and we will touch that portion in a couple of seconds. So
Mhm.
nothing is only black and white. There is some possibility, like in a whole AIAG, VDA, AITF, something is so written and something give you a possibilities.
Mhm. Let me also take an opportunity and say that when we mentioned that in AIAG we can find such information about these values of CP and CPK, we have it in PPAP manual. However, let's be precise. PPAP manual is saying not which index must be used. It's just writing the index. Yes, so it is also to consider what our customer wants. Yes, to calculate. Mm, it is called in the section initial process capability. Yes, IPC. The abbreviation is in PPAP manual. Okay, so important, and this is really very important. First of all, customer specific requirements. Yes, customer specific requirements will tell us what would be the value, yes, for having the process capable. And let me display a question in this place. What a team asks, what is the typical target value in CP, PPK, in automotive? So generally in this place, I think it's a good question to answer. Because on the previous slide, we showed you the manual values, the values from the manuals from AIG and VDA. However, always let's consider that the receiver of our production is OEM, is or other tier and supplier in automotive supply chain. So being in the role of the customer, and the customer always may indicate for us what will be this value. Of course, in the supply chain, we are obliged to cascade the information, the requirements from the customer, the OEM, I mean here in this regard, and to, maintain this, yes. So the information, the knowledge about the values is important, yes. For instance, Mercedes has 2.0 ppk, yes? So this is really high, yes? We need to be aware if we work with Mercedes. Okay, another important, the actual capability requirements will depend on what the customer demands, but it does not mean that it is constant. And we can not say no. Yes. So when we launch the project, this is a perfect moment to negotiate with the customer, or simply just say at the very beginning, before nomination, if this is feasible for us. Yes. Also, let's remember that this may have the impact on the prices of our pieces. That's why at the very beginning, really, in project management, it's extremely important, this first phases where we recognize the customer requirements, but also, let's be honest, from the system, quality management system perspective, when we need to evaluate and judge the customer specific requirements for our quality management system. Yes, so now from the system perspective, I'm telling you. And the last important, this can result to tighter or wider requirements to process capability. And exactly like I said with this example of the Mercedes, yes, 2.0. With 2.0, you will never produce any PPM. Yes, this is safe. Okay. We hope you enjoyed this webinar. It's 9 p.m., so already 1 hour of our meeting. Let's give you maybe a moment to raise some questions on the chat, and we'll give you the opportunity to listen to the answers. In the meanwhile, let me maybe display this, what is important for you. Just that you know that we'll really take it away with us. Let me just have a look if you raise some questions here. So, of course, Anders, Tim gave this question, but we answered already. What else? Here, what would, Vit, maybe you, a question. How can we choose sample? How can we be sure that it is representative to the population?
Yeah. So typically we are taking the samples from the beginning and end of the production. That's what the standard is asking us to do. Then it's difficult to, that's not easy answer basically, because if you start to picking up something, you already degrade the statistic, because you put your influencing and you say, this looks good, so it will be good for my sampling, and you take it. That's not good. If you ask more about the quantities, which is good, there is a possibility, a way how to calculate. For example, if you produce in one shift 50,000 parts, of course, the 30 parts to measure statistically might be not really the best value. Maybe you will need to have a more. So there is also a possibility how to calculate the amount of the samples based on the Z-score and a little bit other techniques, but you might be negatively surprised how many that you have to take and evaluate. So it's very tricky situation. I would say it's difficult to just pick up the things. You need to consider what is your entire population. The standard is asking us to take the beginning and end of the production. That's where we have to take. And you have to consider also the aspects like how long production, how many parts you produce. Based on SPC, do you have any variation? Do you recognize that in certain point of the time, there is always kind of the variation? So there are all the factors which influence your decision, but ultimately it's your decision where you take the sample.
Mm-hmm. And however, also let's pay attention to the indication of these manuals connected to process control, which is how many pieces you need to take while calculating short-term capability or long-term. For the short-term is set 125 in AG, and for long-term we need to have consecutive 20 days of production run, yes, to to calculate later the capability of the process, yes, based on the on this index. Any other question? Maybe not a question, but maybe a comment here. It is important to understand that the most crucial factor to make use of SPC is the rational subgrouping. Otherwise, SPC is useless and only done to satisfy customer, not to improve processes. Yes, especially if we are doing control charts, yes, then subgrouping plays a role. What else? And here maybe a comment more from team. CP tells us if the process has the potential to meet the requirements, focuses on variation. Yes, it's very good that you indicate this variation, because sources of variation, the knowledge of these sources of variation will help us to mitigate the potential risks. Yes, CPK tells if the process is actually meeting the requirements, focuses on both variation and centering. A process is considered capable if these indices are typically 133 or higher, depending on the industry or quality standards. It's good that you gave this in the bracket, because as you could see here, in automotive, a 133 might be too little. Yes. Is there any question more? Here, Tim again wrote, in the meanwhile, how can I agree on a target value if I start a new production? So all the costs needs to be considered upfront: test runs, labor, materials, etc. Wait, maybe you?
Yeah, I think that we know quite well, both of us. This is a tricky point. So, yes, of course, if you don't have the experience before, you rely on a test, on calculations, on the trials, simulations, and this kind of stuff. If you are not sure, I would try to be more conservative in agreement with the customer. Yeah. So it's very tricky thing, and you are absolutely right. So we have to also take in a consideration that, generally speaking, the over quality costs the money. Low quality costs also money. So we need to find a good balance in between these two. So if you have very expensive process, very tight control for something where we don't need, then we wasting the resources, right? We wasting the money, and it doesn't bring the benefit. So the good balance is necessary. Yeah.
Mm-hmm.
But if you start basically somewhere, it starts with a simulation, with a typical precision of the process, which normally your tool manufacturer is able to give you what is a tooling precision, and yeah, some simulations.
Mm-hmm. Let me also put my input into this. In automotive, it's like that mostly, that if we agree to work with such some OEM, simply we agree on the general conditions. Yes, signing the manuals, the frame agreements, in which we have the conditions actually determined. So this generally is the starting point, that we need to stick to these conditions. Also, specifically to each certain project, it might happen that this what was in the frame agreement is irrelevant for this specific project, and in fact, it will be defined by the customer. For instance, if we are talking about special characteristics, especially safety, yes, and no ppms at all. So the value must be definitely high. Yes. Okay. I don't see any more questions. So I think if you would have further questions, you can leave on the chat, and later maybe we can answer in the social media for you to be more confident in this topic. So tonight, thank you very much for joining us. Thank you for your time. We appreciate that you decided, in Europe at least, to spend the evening with us. Vit, thank you very much for joining me in this webinar.
Thank you
If,
very much. And thank you
yeah,
too.
I believe, Vit, that we might be inspired to conduct maybe another webinar regarding in this area of SPC, connected simply to the functional charts. What do you think?
Yeah, I think it's really good item to discuss, because this is our daily life in a quality control.
Okay, so thank you very much once again. We wish you here, at least in Europe, nice evening, and in the rest of the world, West, at least a nice afternoon. Thank you very much, and we invite you for the future webinars to be with us. Thank you.
Thank you very much. Have a great evening and day.